Okay, this is just another basic example of the product rule. So we're doing the product of two things. So I'm going to circle those two things. We do the derivative of that product. Remember, you're just going to write each thing twice. We have ln of x squared written one time, ln of x squared written twice. We have sine of x written here, sine of x written there. And remember, we're going to do the derivative of ln of x squared on one of them and the derivative of sine on the other one. Okay, derivative of sine is just cosine. Now over here, we're going to bring this 2 down before we do the derivative because it will make it easier. So now when we do the derivative of ln of x, we just get 1 over x. And that's it. You can leave your answer like that. It really doesn't matter. Now this one's pretty similar to the other one. I'm just trying to show you the difference. This squared is actually on everything. So you cannot bring it down. When we do the product rule here, we can do the derivative of this piece plus, over here I'm going to do the derivative of sine. The derivative of sine is cosine. Now for this one, we're going to treat it like x squared, so the 2 will come down, and the new power will be 1 less. However, power of 1, you really don't have to write it. And I want you to notice that it wasn't really just an x, it was an ln of x. So we're going to have to do the chain rule, and the derivative of ln of x is 1 over x. And you can leave your answer like that. Remember, you don't have to simplify simple arithmetic. Okay, we're going to solve this one 2 different ways. The first one is just with the quotient rule. So it's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. Another way to do it is just call this piece y. Then we can do ln of both sides. That allows us to use the rules for log. We can separate this into 2 easier pieces. We could even bring this x down. Now we can do the derivative of both sides. The derivative for ln of y is 1 over y, and then y prime. And that's because we're doing the derivative with respect to x, and that was a y. Now this is just a constant. It's just like a number. So if you have a number times x, the derivative is just the number. Now the derivative for ln of sine of x is going to be 1 over sine times the derivative of sine, and that would be cosine. Okay, we're almost done here. Remember, our answer is going to be y prime, and that's because our y is just this, and we want the derivative of y, which would be y prime. So that's why our answer is going to be y prime. So we just need to multiply both sides by y, and we're done. But remember, we can't just leave a y there. We're doing the derivative of a function of x. So having a y doesn't make any sense. So we'll erase the y, and we'll put what y is equal to. And that's your final answer. Now I want you to notice that these 2 final answers look a little bit different, but you can work with either one, and eventually they're going to look exactly the same. In this case, it was easier just to do the quotient rule, but later on you're going to see that it's going to be easier in certain situations if we use logs. Okay, here's an example again. We're going to have to use the log rules. We're going to separate this. Okay, I'm going to write this as 3 logs. Anything on top gets a plus in front of the log. Anything on the bottom gets a minus in front of the log. Remember, you can bring this power down. So put that x at the bottom here. Okay, now let's do the derivative. Now ln of e is just 1. So really, we're just doing the derivative of x for this first piece. The derivative of x is 1. This is going to be the tough piece. The derivative for ln of sine is 1 over sine times the derivative of sine. This here is just a constant. Remember, the derivative of a constant is 0. The derivative for ln of x is just 1 over x. Now you can leave your answer like this. Some people will trade this for cotangent. But there's no need to combine all these into one single fraction. You can just leave it like this. Okay, here's one of those derivative examples that we don't have a rule for. We're doing the derivative of a function of x, where the power is also a function of x. So we're going to start by calling this entire piece just a y. So y is equal to that piece. Remember, we're trying to find the derivative of that stuff. So we want the derivative of y. So our final answer is going to be the derivative of y. Okay, you'll notice we took the natural log of both sides. The reason why we're doing that is because we want to be able to bring this x value down. Here you see it at the bottom here. Now we can do the derivative of both sides. On the left side, the derivative of ln of y is just 1 over y. But that's the wrong letter. We're doing d dx, and this is a y. So that's why we need the extra piece that's y prime. Over here we have the derivative of a product. So on the first piece we can do the derivative of x, and on the second piece we can do the derivative of ln of sine of x. Okay, derivative for x is just going to be a 1. The derivative for ln of sine of x is going to be 1 over sine of x times the derivative of sine of x. That's the chain rule. So we get the cosine of x. Derivative of y is just y prime. But that's good because that's what we're looking for. That's going to be our final answer. We just have to get rid of this 1 over y, so we're going to multiply both sides by y. On the left side it cancels, and we just get y prime. Don't forget to trade the y for what the y was equal to. You might remember from the beginning that y was equal to sine of x to the power of x. So we're going to trade our y for sine of x to the power of x. And now we're done. Okay, here's our last example. This is a product rule, but with 3 things. We have sine, we have f, and we have g. Now, if you remember the pattern for that, that's a product rule with 3 things. On the first piece, I'm going to do the derivative of sine, and I'm going to write the other 2 things. On the second piece, I'm going to do the derivative of f. And on the third piece, I'm going to do the derivative of g. Okay, derivative of sine is cosine. The derivative of f is f prime. And the derivative of g is g prime. So we just did h prime of x, but they want us to find h prime of 0, so we need to plug in a 0. Okay, I want you to notice that because sine of 0 is just 0, that means this entire piece is going to be 0, and this entire piece is going to be 0. Cosine of 0 is 1, f of 0 is 2, you can see at the top, and g of 0 is 5. So it looks like our final answer is that h prime of 0 is equal to 10.